All right, I think we have a great crowd, so let's get started. Hello and welcome, everyone. Thank you for joining us for this installment of the iSamples 2015 Fall Webinar Series. iSamples, which stands for the Internet of Samples in the Earth Sciences, is an EarthCube NSF-funded research coordination network that seeks to dramatically improve the discovery, access, sharing, analysis, and curation of physical samples and the data generated by their study for the benefit of science and society. Our first speaker, Brian Buczkowski of the USGS Woods Hole Coastal and Marine Science Center, will speak about managing physical sample collections at the U.S. Geological Survey. Our second talk will be given by Sarah Ramdeen, a graduate student in the School of Information and Library Sciences at the University of North Carolina. She will speak about her dissertation research on information seeking and physical samples. Just a quick note about the format of these webinars. Each presenter will be given 20 minutes, and then there will be approximately 10 minutes at the end of each presentation for questions. If you have questions, please type them into the chat box during the presentation. Bucky, we will begin with you. I will pass the screen sharing to you, and you may begin when you are ready.
Great, thank you.
Looks great.
All right, thank you. Thank you all, and thank you again, Megan, for inviting me to speak at this webinar session. As was stated, my name is Brian Buczkowski. I'm the Curator of Geologic Collections and also newly the Laboratory Manager for our Sample Analysis Lab at the USGS Woods Hole Coastal Marine Science Center. And also in my job duties, I work in conjunction with the USGS National Geological and Geophysical Data Preservation Program. And working with this project has afforded me the opportunity to work with collections management strategies that have an impact both on local levels and potentially that can benefit the entire survey and beyond. And that's kind of what I want to talk about in this presentation this afternoon. There we go. Just to give a little background information, going all the way back to the USGS. The USGS has a long and storied history of collecting specimens and samples in the course of its mission. And this mission is, and I quote, to provide reliable scientific information to describe and understand the Earth, to minimize loss of life and property from natural disasters, to manage water, biological, energy, and mineral resources, and enhance and protect our quality of life. Going back to its foundation through today, these specimens have an important and rich scientific legacy, and they vary in scope and nature, such as ejecta and meteorite fragments, samples collected across the contiguous U.S. and Alaska for the National Uranium Resource Evaluation Program. Sediment and rock sample collections from marine, fluvial, and lacustrine environments, as well as micro and macro paleontological collections. And important to mention as well are biological collections, as well as water quality monitoring samples, and many other collections that the USGS has collected in the course of scientific research in the field. And this kind of leads to the nature of these collections being maintained by the USGS. These samples are scattered across the U.S. In various locations, in warehouses, in field offices, dedicated repositories, and underneath desks, tucked away in labs. And many of these collections are stored in locations that for which they were originally collected and where the analyses performed on them were conducted. And I feel where they have a huge potential for further investigation and research. But this in itself poses a problem because having these collections spread across all these facilities and they all have different capabilities, priorities, and needs, it makes it difficult to keep track of these collections and to ensure that there's a uniform standard of care. and access. And with that, I'd like to get to where the USGS is today in regards to thinking about collections and collection management strategies. And to do that, I'm taking us all the way back to the beginning of the century, all 13 years ago, in 2002, with the publication of a report released by the National Research Council, which brought collections management forward and took a critical look at how various scientific institutions steward their collections. This report, as well as the subsequent publications mentioned here, play an important role in how the USGS has developed and is thinking about its own collections and how to better steward them for future use. Starting with this report, the Geoscience Data and Collections National Resources in Peril, published by the NRC in 2002, stressed that geoscience data and collections have both immediate and long-term value for resources, as well as engineering needs. But this report also warned that many of these collections are in danger of being lost through mismanagement, neglect, and disposal. Recognizing that not all materials can be kept forever, the report offers recommendations on how to evaluate these collections, where they might be stored, and how to provide access to the materials. And following that, in August of 2005, the Energy Policy Act of 2005 was passed. Section 351 of this act directed that the Secretary of the Interior implement a national geological and geophysical data preservation program with the goals of archiving pertinent geoscience data and collections, providing a national catalog of these materials, and providing technical and financial assistance related to these activities. Following the 2006 release of the Data Preservation Implementation Plan, which happened a year after the Energy Policy Act, the USGS Data Preservation Program has been working to coordinate the data archive system of the federal and state agencies, administer the National Digital Catalog, and provide financial assistance where possible. And as an aside, on September 17th of 2014, the U.S. House of Representatives Committee of Natural Resources held a hearing to discuss legislation which would reauthorize the NGGDPP Act of 2005 through 2019. This is also referred to as the Data Preservation Act of 2014. And there's an article that was published in EOS in September of 2014 entitled Geological Data Preservation Program Receives Bipartisan Support. And this article, which is available online, kind of details the support that the data preservation program at the USGS received from partner organizations, state geological surveys, kind of the testimony that kind of brings to light a lot of good that data preservation can do for not just federal agencies, but state and academia as well. In late 2008, early 2009, the Interagency Working Group released a report, Scientific Collections, Mission Critical Infrastructure for Federal Science Agencies. And this paper echoed the kind of issues and concerns mentioned in the 2002 report in the emphasis on the importance of scientific collections for both present and future research needs. Because many samples prove impossible or prohibitively expensive to recollect, it is critical to preserve and maintain present and future collections in the best of all circumstances. And finally, I would like to mention a 2009 publication from the Inspector General of the Department of the Interior, stating that it found the DOI failing to fulfill its stewardship responsibilities over its museum collections. And specific complaints addressed shortcomings of accessioning, cataloging, inventorying, preserving, storage, all deficiencies that prohibit adequate access to the collections. In this report is kind of like a cold splash of water on the face, and it definitely adds weight to the need to define collections management strategies and adds emphasis to the work that the USGS has done and is continuing to do to address its collections. So the USGS response to all of these kind of encouragements and suggestions was to do two major tasks. The initial task was to conduct a geologic collections inventory, just determine some basic questions and find out answer to those questions, to find out what repositories are out there, what collections and materials comprise what these repositories are caring for, where are they located, and how well are they documented, how much do we know about them. And the second phase was to create a collections management plan, a plan that would fit what these repositories that responded need in terms of collections management and access and preservation and storage. And the collections inventory was conducted using a survey administered by the USGS Data Preservation Program in late 2007, early 2008. And responses to this survey came from 9 different states, resulting in a listing of 65 distinct collections of geological and paleontological specimens. And these range from ice cores to tephra samples, marine invertebrate microfossils, bedrock drill cuttings, coral cores, a whole gamut of geological collections that have been maintained and researched by USGS programs. And to address the second task, which was to create a collections management plan, the National Data Preservation Program brought together a working group to help define needs and strategies and problems involved in managing geoscience material collections. This group first met in 2008 and came together as the USGS Geologic Materials Repository Working Group. And throughout the course of several years worth of teleconferences, a couple face-to-face meetings, this group developed a document called the USGS Geologic Collections Management System. And this document was submitted in, I believe, July of 2010 to USGS management as a way to fulfill that mandate to create a collections management plan for the U.S. Geological Survey. And several years later, the document was revisited by members of the GMR working group. It was updated to include the management of all USGS scientific materials, not just geologic samples, to fit the changing management structure of the USGS into mission areas instead of just geologic and biologic programs. And that brings us to kind of what I wanted to present to the group today, which is a publication that was released this year, the final published version of the USGS Geologic Collections Management System. And this report provides a guide for sample repositories to establish common practices for collection, retention, and disposal of geologic materials that are collected and maintained by USGS programs. The GCMS Collections Management Plan provides a set of protocols and templates for the management of scientific collections. And this includes guidance for access, for storage, transfer, and disposal of geologic samples and data. And this was written and designed with the goal to standardize curation for these samples and data and improve their discovery and access by USGS and partner researchers. Some of the major issues addressed by the USGS are designed to kind of promote questions and answers to help collections managers kind of figure out how to evaluate their repository, their collections, what their goal is and what their needs are, and ways to define a repository. A repository doesn't have to be on par with the Smithsonian. A repository can be a local facility, and what is the responsibility of a repository, and how can that fit what the GCMS is suggesting. How to define your collection, and questions on how to take a look at your materials and figure out how they relate to each other, how they fit into research goals. And the GCMS also helps outline and define specific types of collections, such as active collections, which a lot of researchers have. They're collections that you have that you are actively returning to, studying, referencing, reanalyzing. And that leads to resource collections, which are collections that were active at one point, but now they act as a resource for looking back at legacy data and old data and figuring out what that relationship is. And then legacy collections, which are materials that were collected by USGS scientists that are no longer active and that still have a use for future research, but that use is not imminent or immediate. How to evaluate your collection. And the GCMS outlines a decision tree that highlights a tool that we call the 4-point standard. And that 4-point standard is a series of 4 questions that basically ask what, where, who, and when, to identify what you collected, where it came from, who collected it, and when they collected it. And that provides the basis for essential metadata needed for these samples. And the GCMS suggests that if these criteria, if these can be answered, it qualifies as inclusion in the GCMS. And all that means is inclusion into this collections management system and data management database that the National Digital Catalog can provide to make sure that these samples can be accessed and used in further investigations. And this decision tree also provides solutions for if you can't identify where this hand sample was collected, or you don't know what this core is, ways that you can utilize those for education and outreach. It provides suggestions for that so that the sample is not immediately discarded, either through disposition or through transfer to someone else. And the National Digital Catalog leads into registering your collection. And the GCMS lays out suggestions and templates for registering collections using the system that is promoted is the National Digital Catalog for serving up metadata about your samples. And it also makes mention of utilizing a service such as CSAR for registering your sample online and creating a unique identifier that is specific to each sample, and it helps with sample tracking, and it also provides a mechanism for searching your collections and making them available for outside research. The key components that are mentioned in the GCMS, they help identify and develop an effective collections management plan that is specific to each repository, but it's also kind of fits the need for a unified collections management plan. And it talks about issues such as creating a mission statement, figuring out where you're located and who you serve, what you provide, and what is the scope of your collections and what you're trying to do. Taking a look at authority and responsibility and figuring out who provides oversight and define the roles for each person in the repository to make sure that everything is kind of coordinated and managed in a responsible way. Thinking about management of your collections and what are your storage requirements and how do you address future needs? How do you expand? How do you plan for natural disasters? What are your own metadata requirements and how do you evaluate your samples and collections? And also conditions for accessing your collections. How do you allow access and do you allow access? How do you advertise? how do you ensure that your samples are tracked and kept safe? Do you provide off-site loans, or do you only allow for on-site visits? And to kind of emphasize how this is already being used, the USGS in 2013 formed a committee of collections managers throughout the survey with various backgrounds and in various mission areas to form the USGS Collection Steering Committee. And this group was formed out of suggestions outlined in the GCMS to create kind of a national oversight body that can help various smaller repositories and other agencies and institutions coordinate their efforts to kind of implement a solid collections management plan. I included this slide. These are the original 15 members of the Geologic Material Repository Working Group. And their affiliations on this slide are the affiliations that they had when the group convened and when the report was first submitted. And this may have changed, but these are the individuals that contributed to this document with their expertise and their background and their perspective on how to use samples and how to access materials. I'd like to add this information. If you'd like more information on the GCMS, on the USGS and how it handles geologic collections, kind of any questions on the research that we did and how we came to certain conclusions, you can contact Betty Adrian, who is the program coordinator for the National Geological and Geophysical Data Preservation. Feel free to contact me as well. I'm happy to help and provide any information. And one thing that I would like to announce is how to access this report. The GCMS is available online through the USGS Publications Warehouse. The URL to access this publication is in the announcement for this talk. And also, as of last week and early this week, printed and bound copies are now also available from the printer. You can contact Betty Adrian or myself to request a hard copy. You can also email the Data Preservation Program directly at nggdpp@usgs.gov to request your free copy. In any of those requests, please be sure to include a mailing address so we know who to send it to and how to get it to you. And I would also like to invite everyone to take a look at our website. It's datapreservation.usgs.gov. And we recently revamped our web presence, trying to offer a lot more services. It's still a work in progress, but it's a work that we value and will incorporate input based on, partners and stakeholder suggestions. So if you want to take a look, please take a look at our website, and if you have any suggestions or want to see anything, please let us know. Thank you.
Thank you, Bucky, for that very informative talk. I would like to remind everyone that if you have questions, you should please put them into the chat box now. Let me see if we have any yet. Okay, so Bucky, can you tell us a little bit about what the response to the GCMS has been so far? I know it only came out very recently, but...
Yeah, it's a very recent, but the response has been, I think the response has been very good. It's definitely provided kind of questions, and I know myself, I'm always interested in techniques and the way other people kind of manage their collections and strategies people use, and a lot of inquiries and requests for it, as I would request information and collections management plans. So it's been really well received. Distribution is fairly new, so we're still waiting to hear back from USGS repositories. But yeah, the response has been really good, which makes me very happy.
So in the process of developing the GCMS, were there particular aspects that were more difficult to agree on or more controversial to?
Aspects such as procedures and policies. I can see. I can't remember anything specifically, but everybody that was on the GMR working group has their own perspective and their own experience and their own kind of take on accessing samples and what kind of metadata is required and how do we want to provide this information and what's the best avenue for getting to this spot. So nothing contentious, but if everybody has their own experience, then they brought that to the table, and that's made, you know, for lively discussions, but I think a better document as well.
Well, it's very apparent what a tremendous amount of work it was. So I think I don't see any more questions. I think we should probably move on, but thank you again for your presentation.
My pleasure. Thank you for having me.
Sarah, I'm going to pass the screen share to you momentarily. And you should unmute yourself and begin when you're ready.
I'm ready. Well, I'm so excited for a number of reasons to be speaking with you all. For one, I think what Brian just spoke about is a great introduction, but without, I didn't want to say it that way because it sounds like minimalizing, but it's a great connection point to the work that I'm doing. And sorry, let me share my screen before I get too far into things. And then, okay. Alrighty, so I know a number of you who are on the call right now, and I actually was inspired by a number of you. Beverly and Betty can certainly attest to this, but I'm a doctoral candidate in the University of North Carolina at Chapel Hill in the School of Information and Library Science. But originally I worked as a geologist for 7 years. I worked for the Florida Geological Survey, and in this picture, it demonstrates part of what my job was. It was to find and access information, physical objects for people doing scientific research. And I often acted as like a reference librarian, if you will, where people would call the warehouse and say, I would like all the wells drilled within a certain radius of an area site. And then I'd have to pull records and find if we had the data to fit their needs. And that really inspired me to go back and get my PhD. Between those conversations with other repository managers and also this work that the data preservation program was just starting up to around that time in 2006 was just very inspiring to see, well, what is the other side of things? As opposed to coming at this from the repository or the organization managing its collection, what is the user's perspective on how they're interacting with these collections and whether or not the systems we're building are actually fitting their needs? Okay. So to give you a little bit of background, I'm going to talk about information and access and research. So the way we do scientific research is changing. There's a lot more cross-domain questions being asked. There's a lot more using of specialized software and processing large amounts of data. And historically, with state geological surveys, there's always been this question about whether it's easy or not to access the information that they contain, which is not just the published materials, but also, again, this physical data. And this amount of data is just growing and becoming overwhelming and expected to be this exaflood of data by 2020. But what gets to be the interesting question, in my view, again, is this: we're not sure how these small collections, and state geological surveys are a good example of these, become more public and shared collections, where they go from the individual researcher or scientist collecting data to fulfill their research needs to then becoming a repository that's maybe open to a more larger public. And so in that same sense, there's a need to enable scientists to answer these grand research questions that they weren't asking before without wasting as much of their time in finding, processing, translating data. So I'm taking the viewpoint of information seeking. This is a theory in information and library science that we have different information behaviors, and that those behaviors encompasses our behavior when we're looking for, when we have a need and we want to find information, and then seeking is that specific action of how we go to solve that information need. And sometimes we might not even know that we are looking or thinking about answering a question, and sometimes we might never find a satisfactory response to our information seeking. And one of the classic models in information seeking in library science is David Ellis's work. He has done a number of studies where he has looked at specific science groups like social scientists, chemists, as you can see here on the slide, and looked at how they search for print materials like journal articles in order to do their research. And he developed a series of categories that are such things as starting, chaining, browsing, and we can think about these as the things that you typically do when searching for research. So you might start reviewing typical journals to see who else is publishing on a topic area, what's been done. You might do some chaining where you look at citations to work to find other publications. And things, just other behaviors that are more like this example, monitoring or maintaining awareness, where you're just keeping abreast of what's going on in the field. But how do we do that with physical data objects? Like, it's easier to imagine that with print resources because we have a lot of systems and structures already in place to help us with those. The whole concept of a citation, even for literature, we're still working on what that concept means for physical data and where it will go in the publication. So there's this need to understand a little bit more about how people are doing this searching, but on top of that, it's also how it translates, because if we think about looking for journal articles and talking to researchers and other friends, like that might be different as a concept with physical data because you can also go out and create new data if you can't find it. So there's a little bit of question of what other categories might come up. So again, I'm focusing on physical information sources, and these are materials for my dissertation will be cores and cuttings at state geological surveys that are materials that cannot be replaced with a digital surrogate. You might need a digital surrogate, such as metadata and other records, to provide access and discovery of these sources, but at this time we cannot completely replace them with a digital object. So you might still need to do chemical testing or destructive testing on a rock sample in order to determine the answers to your information needs. And I love this. Brian had a much better slide with a better example of this, but from the GCMS's report, how you do define different collections, is this idea that you might have a sample or set of field collections that are smaller individual scientist collections, but eventually they become part of these larger general and research collections. But the way that the metadata is collected is not necessarily consistent across, even within an organization, or maybe how an aggregate collection develops over time. And there's also points of intervention here where we might start doing things like registering IGSNs or the development of unique identifiers or other points that will allow for easier discovery and access to these samples. And I'm focusing on state geological surveys for a number of reasons. One, because again, my background working at one, but most importantly, they have a public service. They are like libraries in that regard, is that their missions often include providing access to the materials that they collect for the state in which they exist. And there are a number of current efforts. We've heard quite a bit about the data preservation program through the USGS, wonderful program. They've been doing a lot of work with the American Association of State Geologists, who also recently had AGI do a study of how people access their websites and public information. And so, again, there's this look at information, but not necessarily physical data and also not necessarily from the user perspective. And then we have a number of examples like iSamples, which is hosting this webinar, that are looking at developing cyber infrastructure for physical samples and wants to know where some of these intervention points are, where can IGSN numbers be assigned, where can systems be created that allow better access and discovery. EC3, another EarthCube sponsored program, has been taking geologists and computer scientists out into the field so that computer scientists can see how geologists collected data and physical samples in the field and develop mobile apps to help facilitate with that data capture. And there are other international groups like RDA and CODATA who are also considering the same topics, but from a broader perspective of not just earth science, but other domains that deal with physical objects. The common request that I see in this work is that they want to know what the domain scientist actually has to say about it. A number of the EarthCube initiatives are looking at just that, of developing interviews and programs. I think the Science Committee is doing that as well, of finding out what does that individual scientist say about this process and where are the intervention points in their daily life work, as opposed to providing access to systems that we assume will fit their needs. So that's what drives my research question of what is information-seeking behavior of scientists when looking for physical data. What are the steps they actually take and processes and thoughts they go through when trying to solve this information need so that we can then develop systems that provide for that discovery and access. I'm using qualitative research methods. The first part is to implement a questionnaire, which will be sent to which already has been sent to state geologists and their repository managers, and that's to gather some background data. And then I'll follow up with a series of interviews with scientists who have interacted with those repositories to find out about their search process. And I'll use this information to develop categories similar to that of Ellis's that I showed earlier, and develop my own model of information seeking. So this first phase is there's a need for more information. This is a table from a poster presented at a National Data Preservation Program workshop in 2009. Utah was reporting in on the number of visitors that they receive from different categories, but there's not a lot published about who exactly these users are. And it's inconsistent on the methods at which they're reported from each institution. And so we can see here from the literature there's a number of ways of describing who are in these 4 major categories, but we don't have a lot of information about exact numbers and this, like how frequently they visit and what their needs are per se. And so that's what this first part, this questionnaires are supposed to be aimed at, is identifying what organizations have repositories, allow visitors, what types of materials they use, do they have digital catalogs, do they provide access, and how they do that, and then also, again, who is visiting and how frequently do they get visitors. I'll follow that up with interviews with the actual users. And I'm specifically looking at outsiders who are not part of the organization because I want to find out what their barriers are and what the problems they encounter along the way, and where are their points where they say the system would be better if, and sort of document some of those processes of saying here's how I think about solving my information need. When I go to interact with the system, here's where there's a failure point, and then here's what I do next. I'll be asking them a number of questions about their recent work and what role physical samples play in it, and what resources they look for, and also thinking about teaching or training. So asking them if there was a new staff member on your team, where would you point them to as for resources? How would you train them in searching in this area? One of my interests, I think I skipped this on one of the slides, was just this idea that we're living in an age where people feel like if they can't find it on the internet, it must not exist. But that's not always the case if samples are in a researcher's drawer in their office and the only information about it out there is the publication. So how do we solve that gap? I'll be using qualitative methods again for data analysis. I'll be doing coding of the interviews and reflection memos to find connections across what individuals are saying, and sorting and trying to identify these generalizations that I can use to form a model. And some of my expected outcomes, again, are possible new categories that Alice has not identified in print research, but that might show up with physical data. So there might be barriers of access. They can be because of technology, where you just, again, that example of they're in a drawer someplace, but no one knows that they exist because they're not documented anywhere or linked in proper ways. Or there might be ownership issues where perhaps they're in the hands of industry or private collections, and those sites are now restricted and new samples can't be collected. How do you find out how to get information in restricted areas? And then there's also the idea that you might be able to collect new data. So we say, like if you're doing research and there's nothing published, that's your next topic, right? So you're trying to find samples. There aren't any. Now you have to make the decision of how much resources you might allocate towards collecting those, or maybe you might have to give up your study plan and go someplace else. So these are ideas of what other behaviors people might exhibit when they are searching for information. And the major impact is that we want, we want the future. We want to be able to push a button, get our research, and make progress. So we want to be able to have a seamless search process where we're looking for information and we're able to find it and then able to do our work. And that's going to be some of this feature in cyber infrastructure. But there's going to be needs for training then on both sides for that, of how do we train scientists to document their information and create records and metadata to allow outsiders discovery and access, but also potentially the intervention of information specialists and professionals from library science who have skills and training in these areas already might step in and take over that role and become stewards or managers of data and be part of that conversation. So that's all I've got today. Again, this is the background study for my dissertation research, and I can talk about it further now that I'm actually in it and doing data collection. And also on this website, on my website, you can find out more information about this study, and it's password protected, but the password is listed here.
Thank you very much, Sarah.
Okay. How do I give this back to you?
I can take it back.
Okay.
All right. A reminder to everyone to please put questions in the chat box. I know there must be some. So Sarah, can you talk a little bit more about what types of questions are on your questionnaire? I know you alluded to some, but can you talk a little bit more in depth about those?
Yeah.
Maybe one specific aspect.
Just a second, let me open up the document. But some of the questions might be more along the lines of just asking someone how they start their project. So what are their first thoughts when they decide that they want to start looking for information? Do they call up a friend? Do they look through journals? Like, where do they begin their search process? And also, does it matter in their research whether or not the samples already exist? Or is this, because in industry, I've talked to folks from industry, that comes later. Like first there's an exhaustive search with what they already have, then there's a bit of, well, what can we spend money on? And now at the last point is, well, what historic data already exists in a repository? So some just might be where also the look for physical samples falls into their research.
Sarah, do you plan to survey others outside of state geological surveys?
Well, this I'm focusing on state geological surveys for my dissertation. I would love to talk to a broader spectrum of users, but got to graduate, right? But I would be willing to do follow-up studies along these lines, and I'm sure some of the work that I'm doing with iSamples, for example, we're talking to individuals about their practices, and that will be on a more broader sense. So there are some other groups that are looking at this topic.
I believe on Sunday at the iSamples C4P Joint Early Career Forum at GSA, you'll be doing some similar work, correct? Talking to early career scientists about their workflows?
Yes, at the workshop, we've got a mixture of professors, graduate students, undergraduate students who deal with physical materials in their research. And through Working Group 2, I think we're called user stories from the iSamples group, we're asking them to talk about the processes they take when they're doing their research on a more generalized sense, and we want them to draw a workflow diagram for us to show us where that step of physical samples enters into their workflow, and then we can identify points of intervention as to where, if cyber infrastructure was developed, how could it help facilitate easier searching and reduce some of the steps they take along the way.
Okay, well, I think that if there are no more questions, we might adjourn. So thank you, everybody, for joining us today. Thank you to Bucky and to Sarah for your very interesting presentations. These webinars will be archived on the iSamples YouTube channel and linked on the iSamples website for future viewing, so you can look forward to that and you can tell all your friends. They should be there by the end of the week. Please join us for our next webinar on Wednesday, November 11th at 4 p.m. Eastern. All right, have a nice day, everybody.
Thank you all for your time, too, and for arranging this, Megan.